this pen. Here you go.
Oh, that's pretty good.
I am a huge minimalism fan. In this video, we're going to tear apart and reverse engineer this multicolor retractable pen so that we can learn exactly what's going on in this mechanism that allows users to so elegantly and effortlessly toggle colors. This video belongs to a playlist called the Mental Mechanism Library, in which we're going to study products all around us, figure out how they work internally, and save their mechanisms in our Mental Mechanism Library. This is going to make you a better mechanical design engineer. In this video, we're going to first define the parts, then show you the inner mechanisms, show you two of the main obstacles that I faced and how I overcame them, and then a behind the scenes look. Here's the beautiful CAD model of our pen. I like to start out with an exploded view so you can see all the different components that make up this assembly. And we're gonna label them so we can follow along in the narration. Here's the clip barrel, the retractable plungers. We have 4 of them, 4 different colors. A spring, each one of the retractable plungers has a spring. A black cylinder, which they are slotted in, and the barrel. Part 2, mechanisms. Disclaimer, this part was reverse engineered to a degree that's acceptable for educational purposes. So you may see some defined sketches every now and then, or you may see some geometries overlapping when they're not supposed to due to mate limitations. But by all means, this is more than enough, and it's gonna get the job done to explain how the mechanisms work internally. It's important to ask ourselves, how do we think this works before we actually tear it apart? And there are a couple of clues here, so let me remind you how this works. You pull down the red pen, and the red pen is out here, and you're able to color and draw in red pen. And when you pull down the red plunger, retractable plunger, about halfway, the red one immediately pops right back up. So there's a principle that I want you to remember from this, and it's when a part has a tendency to go in one direction, regardless of its orientation, there usually is a spring involved, and that's the case here. This one caught me by surprise. Before I tore this down, I was under the impression that perhaps there was another component here internally that may not be visible to the naked eye from the exterior, but that's actually not the case, because once you look at this clip barrel, once you look at everything internally, what you see from the outside, it's it. There are no more parts on the inside other than what I showed you. But the key is the geometries on the inside of the clip barrel. More specifically, these triangular channels, which I'm highlighting for you in blue, and I'm going to show you from the bottom. They are absolutely instrumental in driving the mechanism. Lastly, I want to show you the retractable plungers geometry, because it's key to how this mechanism works. We're going to isolate it. Obviously, this is the pen that writes. All the ink is stored in here. Your thumb comes in contact with that surface when you push down. But take a look at this internal geometry. It's got what I call a hammerhead and a nose. Now I'm going to show you the inner workings and how it all moves in relation to each other. I'm going to let you take a peek inside. This is what it looks like. You have the heads and the noses basically coming in contact with each other, almost coming in contact with each other. We're going to remove the blue retractable plunger to create less clutter, and we're only going to focus on the green and the red. So let's recap how this works. You have your thumb, you place it on that surface, you're putting a diagonal force on it, which has 2 components, a horizontal and a vertical component. So it's sliding down. Why is it sliding down? Because of the channels that we have, this channel and that channel. It's sliding down, and it stops right here. Why does it stop? Well, you may think that it's because the spring, which has now contracted, is compressed to this distance. But in reality, the reason why the red ball plunger is being held in place is because of the following. This face and this face are coming in contact with each other and is holding the red pen in place right now. So right now you are drawing with the red pen here. because of those two normal faces coming in contact with each other. But the beautiful engineering comes in place when about halfway down with the green, the red one pops right back up. So what's happening about halfway down that's causing the red pen to pop right back up? Let me show you. It's actually this face of the nose that is coming in contact with this face of the red pen. And when they come in contact, it is slightly nudging the red pen towards the left. There's a little bit of wiggle room between the channel that I'm going to show you here and this face over here. There's a little bit of wiggle room, and that causes a displacement when this face comes in contact with the face over here of the red side, and that displacement causes this blue face to no longer come in contact with this face. Therefore, there's not a normal force here anymore, which means that the compressed spring has all of this elastic potential energy, and it will expand and drive this all the way up instantly. So that's the beautiful engineering that's happening. If there's one golden nugget and take-home point from this video, is that sometimes you do not need to add components to accomplish what you want. Prime example was having these inner geometries of the channels, which accomplished what we wanted without the necessity of having to add another component to our assembly. Part 3, the two main design challenges I faced when doing the CAD for this project. This is for my CAD geeks. Problem number 1 was that when I included the picture in SolidWorks and I traced around it, the center line is not the actual center of the photo. And this posed a problem because this inaccuracy was magnified when I did the revolve feature, as you see down here. Once I revolve around the sketch, the solid is not filling out the entire outline. And the answer, the workaround for that, is here in yellow. You can pause the video if you like. And the other problem was that usually when you reverse engineer, orthogonal views are sufficient, like this other pen project that I had here, front, top plane. But for the multicolor pen project, you actually need new planes in 45 degrees. You need to make cuts and all kinds of inner geometries utilizing that plane. So that posed a problem, which I overcame. Behind the scenes look, this is my process of making videos. I'm big on paper and pencil. I first like to sketch out the different components, label them, and really outline where the forces are traveling and how things are moving. Then I write down what I'm gonna say in the video, and I highlight the main take-home points. In the back, I like to do an outline to neatly list everything that I'm gonna tell you in the chronological order, so everything's organized and with a purpose. If you like this video, please like, comment, subscribe. No, too fast. One more time. All right. Ready, go. And show us the real pen.
You gotta practice that.